Greetings, fellow grade 10s. It's Mr. Thatcher again. Look, what we are going to be basically looking at today, we are going to be looking at, different fundamentals of our Venn diagram, right? And now under Venn diagram, we're going to be looking at in terms of what is going to be the significance difference between intersection events and also union events, and also try to understand some of the other events. I know, in terms of it is very, a little bit complicated when now you just go straight to the content without at least understanding the background of it. So now let me just take you through. So we are saying now, before we can even attempt to answer all these questions, I am saying now we are having what we call now inclusive events, right? Or we have events in general. So now under events, look, isn't it that we've discussed that if you are having this now, let's say I draw this for you and I say this is your let's say this is your Venn diagram, right? This is your Venn diagram. Now, this is your cycle, right? Let me just make this so that I can, be in a position to do that. Now, let me just fix this one. Fast. Yes. Thank you. Now, we are saying now, if let's say we are having inclusive events, now what will happen is if between the two cycles, right? Let's say these are your two cycles, right? These are your two cycles, and you are having a shading that is in between here, and you are having a shading that is in between, and this is event A and this is event B. We are saying this shading in between here represent the probability of what? The probability of A and B, right? Which means it represents your probability of A and B, which is the intersection. So every time, whenever you are looking or whenever they require you to to be in a position to determine what is going to be the probability of this, make sure that you understand that what you're looking for, the probability of A and B, it is only the intersection and the intersection only. Are we together? Now, let's say I give you another event. Let's say now in this event, you are given this, right? Let's try and draw it nicely this time around, right? You are given this, and now let's say if this is your cycle, now in this cycle of yours, let's say this is another cycle, right? Let's say this is another cycle. And what happens is, let me just use the highlighter. Now, it is shaded in between here, right? So if it's shaded in between here, in between both of those cycles, right? All of these cycles are shaded in between. Now, what we are saying, this is going to be the probability of what now? This is the probability if this is your A, this is your B, this is the probability of A or B. This is what we regard as your union. So if let's say you are having a value here, 7, 3, let's say 6, 4, and 8, which means you are going to add all of these values for your O, right? So which means you're going to add all of these values in here for you to find out what is going to be the probability of your union. Altogether. So make sure that you are in a position to identify that. Let's see what else now we have. Now, sometimes you can be given that now they want now if you are having this event, right? Now, if let's say this is your event, right? Now, and you are having this cycle here, and you are having this cycle here, right? And now, and what is it that is happening? Basically, your shading is only in here, right? So the only shaded part is here, which means it's only the first cycle, which is if this is A and this is B, which means this one represent your probability of Y, probability of A. How to get probability of A. And please take note, if there was a probability, let's say if we were looking for probability of A naught, right? If it's probability of A naught, which means it's going to be now everything that is not shaded, right? The shaded one is going to represent the what? It's going to represent the probability of A. But the probability of A naught is going to be the what? It's going to be the not shaded part, which means all the not shaded part, it is going to be the one that represent your probability of A of A naught, isn't it so? So when they say A naught, remember this, it means probability of everything except A. All right. Hopefully now this makes sense. Let's see in terms of also what is it that we can do. Now, let's say now in this event, right? Let's say in this event, you are given this diagram. This is your Venn diagram, right? And in this Venn diagram of yours, let's see, let's try and write it nicely here. Now, you are given these two cycles. This is your first cycle. This is your second cycle, right? Please forgive my space. I want us, when we go back to this, then you understand what is it that is required. Now, let's say in this one. Now, let's say in this one, what they want you to do basically, now, let's say the shading, it is everywhere. Now, let's say there is shading everywhere except for the part that is in the middle, right? There is shading everywhere except for the part that is in the middle, right? So what does this mean? So this basically, it means the probability of what? It means the probability of A. This is probability of A and B naught, right? This is the probability of A and B naught. So if we are looking for the probability of A and B, look here. Now for the probability of B, if I can just take you back here, the probability of A and B, it was the inner shading, right? Which means now if you shaded everything except the inner shading, then it's going to probability of not A and B, which means you're looking for everything except the intersection. Right now, hopefully this will make sense to you. Now look, let's just see in terms of country, then now add the last one here so that we can now start answering our questions. Now let's say now the shading is like this, right? Let's say now this is going to be your this, let's say this is your cycle, right? These are your two cycles. This is the first one, this is the second one, and they look very nice, right? Now, what is it that we are going to do now here? If, let's say now the shading that is in here, you are having the shading that is outside, right? There is no shading inside the circle, right? There is no shading inside the circle. There is no shading inside the circle. The shading is only outside. So these represent the probability of A or B naught, right? Remember the A or B, it was this one, which means this one is going to be the probability of A or B naught. Are we okay? So please make sure that when they want you to calculate any of these, probability, you can be in a position to identify from your cycles in terms of what is it that you are given, right? So now let's try then and see in terms of what can we do now in all these questions that we are presented here. And let's see in terms of whether can we now start and apply these fundamentals. Now look, they say consider the Venn diagram at right to help you answer these following questions. Now the first one, so they want you to find out what is going to be the probability of A. Now, and we are going to be looking at this, right? Let me just we are going to be looking at this particular thing. We are going to be looking at this one, right? We are looking at this one here so that you are not confused. So if we are saying what is going to be the probability of A, remember they didn't say excluding B. So everything that is the probability of A, it is this one. You see? Because all these circles, all this entire cycle represent the probability of A. So your probability of A here, it is going to be what? Now it is going to be your what? It is going to be 0, what? 0, 0.3. 0, 0.3 plus what? Plus 0, 0.2. Isn't it so? And what is it that you're going to divide with here? So we are going to divide by what? You are going to divide, I think, by 1 here. Because let's see, if you are having 0, 0.3 plus 0, 0.2, plus now 0, 0.1 plus that. So this is going to be also over 1. Isn't it so? Because that's going to be the probability. Right? So, which means basically you don't even have to divide in here because you're already given this in terms of, your decimals. So this is just going to be 0, 0.3 plus 0, 0.2. Altogether, then that is going to the probability of A. Let's say now the totality of this is going to be 1. So this is same as 0, what? This is going to be 0, 5 as your answer. So this is going to be the answer that you're going to get for probability of what? Of A. Isn't it so? Now let's see. Then what else now are we then going to have? Now they want you to find out what is going to be the probability of what? The probability of A and B. Remember, I said from the shading A and B, we only look where we are only looking at these inner shading, right? Are we together? We are looking at that particular inner shading. So make sure that now you can identify in terms of what you are looking for. So it's going to be this 0, 2. Are we together? So the probability of this now, it is going to be given by what? 0, 2. So this is going to be given by 0, 2 because that's the only part where now you are having what? You're having the intersection. Remember this part in here, it is your intersection. Are we together? Then now, then let's see in terms of what else now are we given. In this one now, in number C, they want you to find out what is the probability of A or B. The probability of A or B. Now, let me just use a red color. It's going to be everything from here, right? Everything from here and also everything from here, right? Which means basically it is going to be what? It's going to be same as 0, 3 plus what? It's going to be 0, 3 plus 0, 2 plus 0, 1. And when you add this, what is the totality that you're getting here? This is 5, this is 6, so this is going to be 0, 6. Out together. Now that is going to be the probability of what? That is going to be the probability of A or B. Now, however, let me just erase here so that you can see what we are required to do. Now, however, now in this one, they say what is going to be a probability of A naught. Remember, I said this thing means A naught, right? This is going to be the probability of A naught. And now when we are saying probability of A naught, we are saying everything except A. Right? We are saying everything except A, right? So now what is then going to be a probability of everything except A? So which means now we are going to say it is going to be, look, the probability, isn't it that we said the probability of A, it was what? It was 0, it was 0, 5 altogether. So which means now here, if we want to get rid of that, we are going to say, look, the probability of A. Now, let me just introduce this thing to you. So we have this, what we call complementary events. Complementary events, right? I think you know complementary or the word complement. So according to complementary events, probability of A plus the probability of A naught is equals to 1, right? So which means now if you are looking therefore for your probability, let's say your probability of A naught, it's going to be 1 subtract the probability of what? The probability of A. So which means in this context, what is going to be this? This is going to be same as 1 subtract, what is the probability? What was the probability of A? It was 0, 5. So which means now the answer that you're going to get here, it is going to be 0, 5 again. But if you don't want to do it this way, look, if this was the probability of A, if this was your probability of A, you see, I've just made my circle again. Now, therefore, the probability of everything that is not A, it is going to be this 0, 1 and this 0, 4. And when you add both of these, you are still getting what? You are still getting 0, 5. So that's how also you can do it. Now, let's look at then number E. In number E, they want you to find out what is going to be the probability of A and B naught. A and B naught, which means now, remember when they say A and B naught, which means they are what? They want everything except for the intersection. So which means you are going to say, look, you are going to exclude this one. This one is going to be excluded. So which means you are going to say it's going to be this one plus this one and plus this one, right? So which means this is going to be 0, 3 plus 0, 1 plus 0, 4. Isn't it so? Remember, we said we are just taking these ones only except the intersection. Then this is going to give you what? This is going to give you 0, what? This is going to give you 0, 8 altogether. That probability of A and B naught, that is going to be 0, 8 altogether. And now don't forget that these type of events, because you know probability of A and B, because they are having an intersection, we are saying they are inclusive. If you don't want to say inclusive, you can always say they are exhaustive, right? Exhaustive. Yes, that's how we are going to pronounce it, right? Either you say inclusive or exhaustive. Why are we saying that? Because look, the probability of A and B is not equals to 0. You have the intersection, right? So if you have the intersection, the probability of A and B is not equal to 0 because you have a value here, which is 0,2, right? So you can see that value. Isn't it so? Then let's then now continue to look at now a number F. They say, what is the probability of C? This one. Look, this one, there is nothing in here. You see, right? These ones are singles, right? So which means now the probability of C, you're going to come in here and just look for your C only, right? So what is going to be the C? It's going to be the 0,4 only, right? So this is going to be 0,4. That is going to be a probability of C. And now look, now they want to find out what is the probability of A and D. Okay, look at this one now. I just said now that probability of A and B, you must have the intersection here. That's what I was pointing at. But if you look at these ones, shame, they don't have anything in between, or they don't have anything in common. So they don't have any intersection. So which means the probability here of C and your D are what are equals to 0. And these types of events that are disjointed, we are saying now these ones now are mutually exclusive, right? We are saying they are mutually exclusive because look, the probability of A and the probability of B, or rather probability of A and B, is equals to 0. There is no what? There is no intersection, right? Hopefully we are getting this thing now, right? Now let's look at now our number H. Now in number H, they want you to find out what is the probability of C and D. Probability of C or D, C or D, C or D, C or D. So if they said that what is going to the probability of C or D, it's simple. You're going to say what was the probability of C? It's going to be 0,4 plus what is the probability of D? It is 0,5. Then that's all. That's all you need to know. That's all. Which means this is going to be 0,9. That is going to be a probability of A or D. Now, the last one now, or rather your I, it wants you to find out what is the probability of C. Probability of C. But it's not just C. Look, there's something here, which means it's C naught, right? Which means the probability of C naught then. The probability of C naught. Look, if 0,4 is your C, and now everything that is going to be not C, it's going to be 0,1 and also 0,5, which means this is going to be 0,5 plus 0,1, which is 0,6. Are we together? Now that is going to be your probability of not C. Then that's going to be your answer. Then let's look at the last one now. They want you to find out what is the probability of not C and D. Look, now they say what is going to be the probability of not C and D. Look, since you are not having anything here, so everything, this is going to the probability of not C and D, which means the probability of not C and D, look, it's going to be 0,4 plus 0,5 plus 0,1. Altogether, because we want everything except for the intersection. But since we don't have the intersection, we are going to have these as your one, which means the probability, which means you are having 100% chances that you are not going to have the intersection in here. Right now, hopefully now this will make sense to you in terms of understanding the difference between your intersection and also your union. Thank you very much.